Okay, today I will give interview, so you can ask. Okay, one by one. Pawan, you start from your side.
Okay.
Pawan. Uh,
Okay. So, Ansuti, what is the basic difference between the Boger slab correction and terrain correction?
So the burger plate correction is due to the mass between the datum plane and the gravity station. Uh, in the train correction, due to the topography around the station. For example, if there is a hill or a valley, and according to it will affect the direction of the gravity. So this is the main difference. We are taking the gravitational attraction between the datum and the gravity station. There is due to the topographic correction mainly.
Okay. Why we are always at terrain correction?
So to understand this, let's take example of the sorry. For to add this, let's take the example of the hill. Suppose our gravity station is below the center mass of the hill. Then the center of mass of the hill, if it is above the gravity station, then it will attract the gravity in the upward direction. So uh, resultantly, it will decrease the gravity, and to compensate with the uh, observed value, we will have to add this corresponding correction. In the case of the valley, the center of mass of the valley is below the station. Suppose if we fill the valley with the imaginary with the rock up to the station level. Where we have a station, we will fill the valley up to the station level, and so when we will observe the gravity, it will increase by that particular correction. But in actual, there is no mass in the valley, so it will also decrease the observed value. And to compensate this, we have to add this corresponding trend correction there.
Okay, okay. Do you know about in which area we obtain the Boger anomaly positive or in which area we obtain the Boger anomaly negative?
Sorry, I don't know about.
Don't know. And what is the hygiene principle?
According to the Hygiene principle, and the wavelets, each point on the wavefront acts as the secondary source of the wave, where they degenerate, and it actually defines the wave propagation of the wavefront.
Okay. What is the wavefront?
Wavefront is the uh, wavefront define the possible direction of a wave. For example, in the point source, the wavefront is the spherical surface. So each point on the spherical surface, if we connect all points, it will create the spherical surface. And then, as per the hygiene principle, each point on the surface will act as the secondary source. And if it did take their forward direction and make the tangent to all and connect, then it will show the future position of the all the points. That is the propagation of the wavefront. So
Do you
wavefront
know?
is yes,
Do you know any example of the spherical wavefront?
spherical yes, spherical wavefront is generated due to point source. And in the geophysics, the p waves has the spherical wavefronts, p wave and s waves.
What is the P wave and S wave?
P waves and s waves are the body waves, which are the seismic waves and which travels through the interior of the earth. which carry the seismic energy, and from a particular point, the energy is released and they carried by the seismic waves.
Okay. How to separate local and regional gravity anomaly? Any method we
Yes,
can?
there are several methods. For example, the visual analysis. Visually, we can separate the residual and the regional anomalies, but this method has some limitation, like it depends on the experience and the skills of the observer. Secondly, we can mathematically take the point and take the corresponding polynomial, and using the least square fitting, we can also use there. We can also consider uh, these anomalies as periodic in time, sorry, periodic in the in the position, then use the Fourier series analysis. We can also do this, and also by the Fourier transform, because gravity anomalies are not periodic in position actually.
Okay. Do you use a word list square fitting? How to do list square fitting?
Sorry, I am not right now able to recall the exact process.
Oh, okay, okay. Uh, Ansudeep, gravity anomaly depends on parameters. Do you know?
Yes, gravity normally depends on the density contrast of the rock and the hosting rock, that is surroundings, and also depend on the depth of the buried object, and the dimensions of the object.
Okay.
So,
So you have a ore body, it have a density rho 1 and surrounding density rho 2. है ना? Depth of the ore body is Z1. है ना? If rho 1 is greater than rho 2, so you obtain the gravity anomaly. So the peak of the gravity anomaly is positive or negative if the rho 1 is greater than rho 2.
where rho 1 is the density of
Ore body.
okay, so density contrast is the difference between the density of the or body and minus density of surrounding. If it is body, in this case, density of body is greater than the density of surrounding, so the sign of the um, density contrast will be positive, and it is directly related to the sign of the anomaly, which is also be positive.
Okay, okay. So thank you, Ansudeep. I am done.
Thank you.
Sanu, you can start.
Okay. Am I audible now?
Yes, son.
Okay. Okay, in art internal structure, so what type of discontinuity we have? Means you can name some discontinuity.
Sorry, I'm not able to recall.
Okay. What is difference between the regional and residual anomaly?
The when we have the anomaly curve, so the extent of the anomaly curve represent the wavelength of the curve. So if a deep buried object will lead to the more extended anomaly curve, but the less in the amplitude. So this is known as the regional anomaly. But on the other side, if it's a shallow object, then it will create the less extended anomaly curve, but high in the magnitude. And this is known as the residual or the local and gravity anomaly.
For mineral exploration, which anomaly we are more important?
Yes, so minerals mainly, if we take in the crystals, so for the commercial purpose, the shallow buried object are important. That which means the local gravity anomaly is important for the commercial interest.
Okay. Then earthquake scale. So how many scale we have?
Okay. So mainly earthquake size is determined by the intensity scale and the magnitude scale. Intensity is where it is the qualitative measure of the earthquake, that is a physical parameter which is we are measuring here is the energy. But on the magnitude scale, it is the actually sorry, I have intensity scale is that what a observer feel at a particular point. But magnitude scale is the measure of the it is a quantitative scale. So we can quantify some physical properties in terms of the magnitude. And in the magnitude scale, we have the Richter scale, body wave magnitude scale, surface body wave magnitude scale.
Okay. And we also have moment magnitude also, no?
Yes, there is the moment magnitude scale, which
So
is the more
which
yes,
okay, okay, continue.
which is the more reliable scales because the Richter scale, body and surface wave magnitude scales, they saturates at the larger earthquakes. So we have a more reliable scale known as the moment magnitude scale.
Okay, means moment magnitude is more scientific now.
Yes, it is more scientific and reliable.
Okay, then you tell me that energy release in earthquake. So what is relationship energy and the magnitude?
Um, it is a logarithmic relation between the energy and the magnitude. So
And which magnitude we are taking mainly?
here it is the surface wave magnitude. Actually, formula is different for the surface and body waves.
Okay, then why if the moment magnitude is more scientific, then why we are not taking moment magnitude for energy calculation?
Yes, there is also this formula in the terms of the moment magnitude scale, and but right now I'm not able to recall the exact formula. But yes, there is.
Okay. Do you know about the seismic gap?
Yes. Uh, Seismic gap is the part of the active fault line actually in the seismic belts, which is actually part of the active fault line which is inactive in nature. For example, in the central Himalayan belt, central Himalayan gap, so it is inactive since last 500 years because it has not experienced any larger major earthquake greater than the 8 amplitude since last 500 years, and they are the more potential areas for the future earthquakes.
Okay. So tell me about that geode undulation.
So geoid undulation is the difference between the height elevation difference between the elevation of the point on the geoid and the reference ellipsoid. It can be positive and it can be also negative.
So when will be it positive and when it will be negative?
So when geoid is uh, it can be positive in two cases when there is the mass axis below the reference ellipsoid or there is mass or hill some like hill or mass above the reference ellipsoid. In the both cases, it will be positive, and it can be negative when the geoid is below the ellipsoid.
Okay. As the next question is that what is difference between the S wave and the relay wave?
S wave and relay wave.
Yes.
So S waves are the body waves. Relay waves, the surface waves. So surface wave travels near the surface or the near layer, which layers which are near the surface. And for the we take the wavefront, then in the case of the S waves, as they are body waves, so their wavefront is spherical in nature, and wavefront of the relay wave is cylindrical in nature. So due to this, the S waves will arrive at the seismograph first as compared to the relay wave. Now, if we talk about the mm, motion, the particle motion, then it is yeah. Please, can you give me 1 minute? So, and the motion of the S wave is transverse in nature. So, if the motion of particle is perpendicular to the direction of propagation here, so it can be in the horizontal as well as the vertical direction, which is the horizontally polarized S wave and vertical polarized S wave. But relay waves are the combination of the P wave and the SV waves, which forms an retrograde ellipse in the vertical plane.
Okay. Can you give some example of the relay wave we are commonly seen in?
Sorry, right now I don't know the.
Okay. Do you know that the seismic wave attenuation? So which factor they are depending on?
Attenuation depends on the uh, geometry. Sorry,
Means you tell me that the attenuation body wave and surface wave how it depend, how it as it propagate, how its intensity varies.
okay. So intensity is directly related to the energy propagation. In the body waves, the energy propagation is through the cylindrical, through the spherical wavefronts. But in the surface wave, energy propagation is by the cylindrical wavefronts, which means in the case of the body waves, the energy is proportional to the 1 by r square. And in the case of the energy is proportional to the 1 by r. So there is rapid increase in the case of uh, the body waves.
Okay. So what factor these attenuation and depend? Means why the wave are attenuated? What is the basic reason?
Sorry, I'm not.
Are you go? Okay, I'm telling simply. Means which properties is dependent? Why the wave are attenuated? Means some reason like elastic properties, something. Which factor the
Sorry.
energy are loss? The reason for energy loss? Why wave energy is losing? When a wave is propagating in a medium, why energy is losing?
So wave, because it will encounter with some resistance or the impedance in the medium.
Okay. Okay. Do you know the quality factor?
Yes, I know, but
Okay. Okay.
not.
Currently not able to recall.
Yes.
Okay. Okay. No problem. So you talk about the free oscillation of Earth, na? So how many type of free oscillation of Earth?
Yes, larger earthquake effect produce the triggers the free oscillations of Earth. So they are the spheroidal and the torsional oscillations of the Earth. Both are the independent from each other, and in the spherical oscillations, the Earth vibrates along the radial directions. But in uh, the torsional motion oscillations, Earth or vibration of the Earth is perpendicular to the radial direction.
Okay. Okay, I'm done. Can anyone ask question? Can I?
Okay. Arpita,
Hello, am I audible?
Hello. Yes, sir.
Actually, what is gravity wave?
Sorry, I don't
Okay,
know about.
so can you tell me what is the value of the gravity on moon?
Sorry, will you
What is
please
the
repeat?
value of gravity on moon?
It is 6 G by I think 6. It is G by 6 where G the acceleration on the Earth.
Okay, but on what principle does the gravity method works?
Yes, the gravity method works if there is the mass difference between the rock and the hot rock. So it is due to the uh, uh, density contrast, and density contrast will affect the there is will lead to the variation in the gravity. If there is a variation in the gravity, it lead to the mass in the variation of the mass, and then the variation of mass will affect the length of the spring, and that can be measured. So this is the
I'm
basic.
asking about the principle on which any law that holds for the gravity method.
Yes, it's um, works upon the Hooke's law mainly.
No, it's Newton's law, I think.
Yes, there are actually two laws involved. And the first is the Newton's universal law, and the in the gravity instruments, gravity meter, we use the it principle is the Hooke's law.
I'm generally asking about on what principle does gravity methods work?
Okay, it is the Newton's law of gravitation.
What is it?
So according to the Newton law of gravitation, there is the always the attractive force between the two uh, masses. For example, if we take the 2 point masses, then the force exerted by the mass 1 on the 2 will be the g m1 m2 upon r square, where r is the separation between the 2 point masses, and m1 m2 is the mass of that point mass, and g is the universal gravitational constant.
Okay, what is the value of the universal gravitational constant?
It is 6.67 into 10 to the power minus 11 Newton meter square per kg square.
Okay. My next question is, if there are two bodies, one एक का weight 10 kg है and the other's weight is 1 kg, whose acceleration due to gravity will be more?
So gravitational of actually formula in this case will be the gm by r square. So the m, the body which has the larger mass will have the greater acceleration.
You are saying that A depends upon gm by r square.
Yes,
What is m here?
m is the mass of that object on which
Are you sure? M is the mass of the object.
hmm, yes.
Okay. Okay. Now tell me, what is gravimeter?
So gravimeter is the instrument to which measures the variation, the vertical variation in the gravity.
Okay. What are the types of gravimeter?
Yes, there are two types of gravimeter, the stable and the unstable gravimeters. And
Okay. And what type of gravimeters are we using nowadays?
nowadays we are using the unstable types. Mainly, also types. They are the absolute and the relative gravimeters. There is the further subclassification in this. This, as I told, the stable and the unstable gravimeters.
Okay. And why are we using unstable gravimeter nowadays and not the stable ones? Can you explain the difference between them?
Yes, unstable gravimeters are the more sensitive.
Okay.
So, due to the more sensitiveness, we are using these.
Okay. Do you know the term zero length spring?
Yes, I know.
Is it?
Sorry, अभी याद नहीं कर पा रहा हूँ.
Okay. Can you tell me whether the gravity field is scalar or vector?
Yes, gravity field is a vector field
How can you say that?
because it it's directed towards the center of the earth.
Fine. Uh, One more question. Can you tell the different units of gravity?
Yes, in the CGI for in the CGI units, it is the centimeter per second square. In the SI units, its value is meter per second square. And the in the geophysics, we because values are very small, so we use in the gal. One gal is the 1 centimeter per second square.
Why do we need gravity corrections?
So gravity correction because in the gravity anomaly uh, is a comparison between the measured and the theoretical values. But uh, before comparison between these two, we have to make our observed value at the same level with the theoretical because our theoretical formula is reference to the ellipsoid. But in actual case, station can be above the that reference plane or below the reference plane. There can be any mass between the station and the that reference plane, that is the ellipsoid. So before doing the actual gravity survey, we will have to correct each measurement before the comparison.
Okay. What is the difference between anomaly and the correction?
So correction is mainly due to the on which the gravitational acceleration depend, like elevation, latitude, and other factors like mass, the mass between the station and the ellipsoid reference plane. But Gravity anomaly is the difference between the corrected measured value of gravity and the theoretical value of the gravity, which is mainly due to the density contrast due to the underlying rock.
And how the can you know? Can you explain the gravitational potential term?
Gravitational potential is the um, gravitational potential is the work work done by an work done to take exact from infinity to a given point, given mass distribution per quanta of mm, gravitational field, which is the unit, which is the mass actually.
Hmm. One more question. Is there something called zero gravity?
Yes, zero gravity is there. Um, we generally, for example, we feel zero gravity in the a free falling lift. If a observer in the free falling lift, then he will observe the zero gravity.
Can we say that there is no gravity in space?
No, there is also gravity in the space, but it cancels out. But
Okay, I'm done.
net effect of the gravity is zero there. That's why the person in the space is the massless.
Thank you, Ashwin. I'm done.
Mona,
Yes. Acha, Ashudeep, can you tell me what is ambiguity in gravity value?
Yes, ambiguity is the because the different density contrast can lead to the same result. So we will encounter with the interpretation problem. So this is the problems of the all almost all geophysical methods because
Is
solution
this
is non-unique.
okay? Is this only due to density contrast, or there is anything else also?
Yes, in
I
the
mean,
yes
yeah, but
because this is the problem of the actually inverse problem actually, and in the gravity method the density contrast is the physical property which lead to the change in the gravity.
okay. Now, now tell me one thing. In case of a faulted zone, what type of gravity anomaly you can observe?
Sorry, I'm not able to recall.
Okay, no problem. Uh, Tell me another thing that we are choosing a base station, right? In case of gravity surveying.
Yes.
Okay. So, where should you prefer to choose the base station? In the field area, I mean, where you are expecting the anomaly, or in a pure area where you are sure that there is no anomalous zone.
Yes, in the we have to take the base station because uh, like
Where
several
to
correction.
take?
Yes, because several corrections like the drift correction that need to be
No,
uh,
no, you are not getting my question. Please listen it first. I am just asking you about where to choose the base station. We will choose it at the survey area, or we have to choose it at a barren area where we know that there is no anomalous body underlain. My question is that where do you want to choose the base station?
sorry, I don't know about this.
Okay. Can you please name one aesthetic gravimeter?
The Laram Larombe Costo gravimeter.
One second, please. I can't hear.
La Coste Rombo gravimeter is
Okay, okay.
example.
Yes. Okay, good. Anything else?
Yes, they are more, but
Okay.
अभी
Is
याद नहीं.
okay. Uh, do you know what type of gravimeters are presently used in the field? I mean, what is the name of the gravimeter that is presently used in the field?
Sorry, I don't know about it.
Okay, no problem. Hmm. Acha. What type of gravity anomaly is shown by a spherical body? What is the shape of the anomaly?
So, for the spherical object, the curve of the gravity anomalies Gaussian curve, which is symmetric about the line which passes through the center of the uh, sphere.
Okay. And can you please tell me what is the relation between depth and x half in case of a sphere?
Sorry, will you please repeat?
Can you please tell me what is the relation between depth and x half, where x half is the half matlab half maximum of anomaly
Okay,
in
okay,
case of a
I
sphere?
got it. I got it. So, depth in relation between is the z is equal to uh, 1 by 3 half z half, where the x half is the half maximum width.
Are you sure that it's 1 by 3 or it's 1.3?
It is 1.3.
Okay. Now tell me, do you know about overcompensation, undercompensation, and isostatically compensated zone?
No.
No issue. Mm, okay, then now tell me, if we go by the depth, okay, then what type of wavelength will exist and what type of wavelengths will be chopped out? If we go with if we are going deeper in the earth, within the earth, what type of wavelength will exist, longer or shorter one?
So, the for the cell object, the extent of the curve will be narrow extended curve, so wavelength will be low. As we go deeper, then extent will yeah, the curve extent of the curve will increase, and so in the initial case, the curve the wavelength will be less, and it will increase with the depth.
Good. Now tell me, what is the use of gravity magnetic in case of hydrocarbon exploration? Leave magnetic, tell me only gravity.
Yes. So gravity method is mainly depends on the density contrast of the material. So the as we know, the minerals have the highest density. So its method is useful for the exploration of the minerals mainly.
I am talking asking about hydrocarbons, not minerals. Okay, no
Yes,
issue. Tell me
yes,
one.
it can also use for the minerals, but it or for the hydrocarbons, fossil fuels. But mainly we use for it the minerals.
Can you please name one mineral that can be detected by gravity method?
Sorry, I'm not able to recall the name.
Okay. Now, do you know any isostatic models? The name of the isostatic models?
Yes, they are mainly two models, the Aries model and the Pratt's model.
Good. And what is the basic difference between ARD and Pratt model?
Yes, in the Aries model, we consider the all blocks with the same density but different thickness. But in the PAT model, the constant depth with the varying density. So all blocks uh, are floating at the same depth but having the different density.
Okay. Now tell me the last thing. If there is a igneous rock, okay, and there is a sedimentary rock, and
Yeah.
in both the cases, the gravity, the host rock is same, then which one will show you then which one you will show positive gravity anomaly and why? Positive Booker gravity anomaly and why?
Sign of the gravity anomalies depend on the sign of the density contrast. So,
Okay.
so the positive sign of the gravity will be in the case when uh, the ore the density of the ore body is greater than the its surroundings. Uh,
Yeah,
but
that's fine. But I have given you two case,
yes, yes,
igneous
but
rock and sedimentary rock. So you have to tell me, and I am giving you the situation that one is giving positive anomaly and the other one is giving negative anomaly. Now tell me which one will give the positive anomaly, igneous or sedimentary? Here, igneous and sedimentary are the intrusive body or ore body. I can say. So tell
yes.
me which one will show positive.
Actually, I am not able to recall the values for the igneous and sedimentary.
Okay, no issue. I can give you a hint that, not hint, it's the answer actually, that in case of sedimentary rocks, the density is lowest. Then comes
Yeah.
metamorphic, then comes igneous. Igneous rocks are highly dense.
Yes.
Okay. Hello? Hello?
Just someone continue.
Okay. Okay, this all from my side.
Vimal,
Yes. Um, Asudip, what are earthquakes? Hello. Hello. Am I audible?
yes, Vimal, yes, audible.
Yes. What are earthquakes?
I think
Asudip?
some net issue from Sudeep side.
Okay. Okay.
Yes,
Asudip?
please. Yes, please.
Yes. What are earthquakes? Can you define earthquake?
Earthquakes are is the shaking of the earth crust due to the release of the strain energy from the Earth's interior through the elastic waves.
Okay. How do we locate earthquakes?
Uh, Means how can we find the location?
Yes.
Okay, so the location we need the minimum three number of stations to find out the epicenter on the on the surface, the location on the surface of the Earth. Then with first we will take the epicentral distance as the radius of the circle, and we will draw that circle. And similarly, as with the center as the we consider station as the center of the circle. And similarly for the other two station, we will draw the circle, and the intersection point of all the three circle will lead to the location, the epicenter of the earthquake.
Okay. How do you find the distance? You just told that you will find three distances, right? How do you find these three distances?
Yes, epicentral distance uh, can be yes, it can be calculated by the Vadati diagram.
Yes,
So
yes.
so from there we can estimate the epicentral distance.
Okay. Okay. How can we how can we determine the timing of an earthquake when the earthquake has
Yes.
happened?
Okay.
Yes.
Yes. The
Yes.
prediction of the occurrence time of the earthquake is it is quite difficult actually. But yes, there are several indicators like the unusual animal behavior. So
No,
animals
no, no.
generally,
No, I'm just asking the timing. I mean, if an earthquake has happened, okay, when has it happened? We can calculate it from Vadati diagram.
okay, from the Vedati diagram.
Yes, yes.
Uh, so the
The timing, right? Yes, yes.
timing, the slope of the Vedati diagrams gives the uh,
No, it is
a
actually the
ratio.
intercept of the x-axis. Okay, in the Vadati diagram.
Okay, okay, that is the origin time
Yes,
of an earthquake.
yes, yes. That is the origin time.
Okay, okay,
When the earthquake. Okay,
thank you for this.
okay. What is the basic principle of moving coil electromagnetic seismometer?
So the it is depend. Its principle is the Faraday law of induction. So the changing the changing flux through the coil lead to the potential difference. Hello,
Yes, we continue.
am I audible?
Yes, yes. Hello, Bimal.
Hello,
Yes, I think some network issue from Bimal side.
I think.
Okay. Gauri, can you start?
Okay, okay. Dev, what is
Yes.
the principle of seismometer?
Yes, a seismometer it based on the principle of inertia, where is a heavy mass, and if a heavy mass is mounted using the stand with the losing wire, so when there is a relative motion between the mass and the ground. So in that condition, that heavy mass does not move, and that relative motion can be detected by the seismometer.
Okay, how many ways can you divide seismometers? What are the types, divisions?
Yes, if depends on the which motion the in which direction it detect. So we can generally divide the on the motion of detection, the horizontal and the vertical type seismometer.
Okay. Um, can you differentiate between seismograph, seismometer, and seismogram?
Yes, seismograph is consist of the receiver and recorder, but where the seismometer is the instrument to detect the elastic waves that are generated by an earthquake. And seismogram is the a real-time virtual record of the earthquake, like the ECG in the case of medical. So it is the physical some document l- like.
Okay. Can you describe the equation of seismometer? Yes.
Sorry.
You don't need to tell the equation. You just say what type of motion it is undergoing.
Yes, sir, it follows the actually the force oscillations. There is the damping there. Uh,
Okay. Um,
but
why do we use damping in seismology? Seismometer.
sir, because early seismometers have the very specific the frequency range. To increase the frequency range, the damping was introduced in the seismometer.
Can you explain it once more? I didn't get the point.
In the early seismometers, they are the undamped because they are very restricted to the certain frequency response, which is very low range. So the damping was introduced to increase the frequency response of the seismometers.
Okay. And do you know what is the range of damping factor we are using in current seismometers?
Sorry, that I don't know.
Okay, then what is long and short period seismometers?
The short and long wave seismometers are they respond to the short frequency, the point 1 to 1 0.1 to 1 second, the short wave period seismometers, and the in the long wave, if there is the time period to greater than 10 seconds, they we are using.
Okay. What is a broadband seismometer?
Yes, because the range of the short period thermometer is 0.1 to 1 second, and the long period thermometer respond to the greater than 10 second. So there is the a particular time gap which is uh, remained unresponded. So the broadband seismometers are there so that we can analyze the whole range of the waves.
Yeah, that's all from my side.
Okay, thank you.
Okay. And Mohit,
So, Arshdeep, can you briefly tell me something about yourself?
Okay. My name is Ashudeep, and I have done my schooling from Bijnor, Uttar Pradesh. Then my graduation and post graduation from University of Delhi. In the second year of my master, I took the experimental nuclear physics as my specialization. Then I also qualified the NET JRF, and the from last 2 years I am solely preparing for the this and the similar examinations, and now I am here.
Okay. Which kind of minerals found in Bijnor most of time?
Yes, Bijnor is actually the area very near to the river Ganga. So sorry, I am not able to recall the minerals.
Okay. Any geological structure or geological thing that you know about Bijnor?
The Sorry.
You know that seismic zones are divided in five types, right? Four or five types. So in which zone your Bijnor side is counted?
It is in the zone 4.
Zone 4.
Yes, because it's very near to the Delhi NCR. So it is because Delhi NCR is also in zone 4.
Okay, so what are the possible values of magnitude of an earthquake in zone 4?
Can go from the 5 to 6.5, something around.
When last time earthquake came in Bijnor? Can you tell me?
Last uh, the major earthquake was the that was occurred actually failed in this area in 2001. That is his epicenter was in the Gujarat Kutch.
Did that affected Bijnor also?
Yes, the vibration also felt here.
Okay. And you said that your specialization is nuclear physics, right? So
Yes.
what are the basic principles of nuclear physics that we can use in the geophysical survey?
So for example, in the earthquake, like the radiant gas in the prediction, and it is the natural product of the uranium, which is which get by the radioactive decay, and
Any other principle? Your voice is not clear. Can you repeat it once? असुदीप आपकी आवाज नहीं आ रही है क्लियर.
hello.
हाँ
Yes,
असुदीप.
now I'm audible.
Yes, now it's okay. So you are talking about the principles of nuclear physics.
Yes. Yes. So the in the density for the density determination we use the gamma gamma logging. There we use the principle they are using the scintillator counter like the Compton scattering, photoelectric scattering, and also in the we use the fundamental law of the statistical decay law of the radioactivity in the geochronological methods.
Okay, you use the term gamma gamma logging.
Yes.
Which physical properties is determined by using this gamma gamma logging?
Okay. We determine the density of the surrounding rocks using this.
We find out the density.
Yes.
And in, in gravity meter, in gravity method, we also determine the gravity, right?
Yes.
The density, right? So which one
Yes.
is more useful?
Actually, In the gravity, we generally see the density contrast, not the absolute value of the density. But
Okay.
here, in these are the actually methods. Gamma gamma logging is the method to find out the actual value of the gravity.
Okay, good. Next question is, what is your hobby?
My hobbies uh, they're moving, watching science fiction movies, and for extracurricular activities, I used to do a physical workout.
Sorry, can you repeat what extracurricular activity?
I used to do workout to keep
Okay,
myself active.
okay. And you said that you watched the science fiction movies.
Yes.
Which science movie you have watched?
Sorry.
Name any movie, sci-fi movie that you have watched recently.
Yes. Yes. Recently, I have completed the Lost in Space series, which is based on the space exploration,
Okay,
and yes, and the uh, like concept of the quantum tunneling.
okay, okay. We know that these geophysical methods are used to determine the structure of Earth, right? So can we use it in the space exploration also?
Mm, the for the space exploration. Sorry, I will have to look upon it.
Any geophysical principle do you have seen in the in this movie? This the you talk this
Yes,
name of the
yes,
movie.
they talk about the gravitation, universal gravitational law there, its effect,
Okay,
and also mm, and the multi-space, the dimension breaching.
okay, okay. Thank you.
Thank you.
Okay, Mohit. So,
Yeah. Vimal
Anu,
can right.
I think all are completed.
yes, yes, yes. So you can give some feedback for Amsuddin, Sanu.
Okay. Okay, Asudevi's communication is
Just
good.
just
And
1 minute, Sanu, please. Actually, I'm taking a pen and note. I will note down because I have done a lot of mistakes.
no, no, it's, for my question, it's good.
Yes, please.
Okay, your communication skill, what I find that it's good. You need to be little bit improved. Okay, but it's good. And your also confidence level also good. And your understanding of the question means you understand whatever properly, whatever asked. And I ask all these questions mostly you answer correctly, but I asked two questions about that. But you can get an answer in glory also. So attenuation factor and the quality factor. The attenuation factor is dependent. So it
Actually,
is
on the serious note, uh, I haven't covered the last part of the syllabus in these two methods also. But जहाँ तक मुझे जो पढ़े थे वो मैंने बेस्ट अपनी तरफ से एक्सप्लेन करने की कोशिश की है.
okay. No, it's good. Yeah. Means, okay. Okay. Can other
Thank you.
comment?
Arpita?
Yes, आशुतोष your communication was good. डिफेंड भी आपने अच्छा किया, बट आप थोड़ा सा जो प्रॉपर डेफिनेशंस हैं वो आप एक बार देख लेना कि एटलीस्ट आप वो चीजें ना वहाँ पे क्रिप करो. ठीक है, और मैंने आपसे एक चीज पूछी थी, दैट ग्रेविटेशनल फील्ड इज वेक्टर और स्केलर, आपने वेक्टर बोला था बट इट इज स्केलर, क्योंकि ग्रेविटेशनल फील्ड हमेशा डाउनवर्ड की तरफ ही पॉइंटेड होती है, तो दैट्स व्हाई द ग्रेविटी फील्ड इज स्केलर इन नेचर. And I also asked about what are gravity waves. Basically, these are the waves that propagate on a liquid surface, or we called it as a ripples, uh, that survive through the effects of the gravity. And, हाँ, और एक चीज और पूछा था, वाई द जीरो ग्रेविटी वाला आपने सही बताया था कि इज देयर एनी ग्रेविटी इन स्पेस. ग्रेविटी इज एवरीवेयर, बस ये होता है कि हम जैसे जैसे अर्थ से दूर होते चले जाते हैं तो ग्रेविटी का इफेक्ट कम होता चला जाता है. तो ओवरऑल इट वाज गुड.
Thank you.
Arpita, can you repeat what is the gravity wave?
हाँ, waves that propagate on a liquid surface, or we call it as a ripples through the effects of the gravity.
Are these are the same as the gravitational waves?
Yes, these both are the same.
Okay, okay. So gravitational waves are the a collection of the gravity quanta, the graviton, which generated by the extreme gravitational like explosion, like the creation of uh, uh, the black hole, or the destruction of a black hole, like merging of two big large celestial bodies.
हाँ,
So
कह सकते हैं, बट वही है
yeah.
कि अगर हम बहुत ज्यादा डेफिनेशन में जाएंगे तो हमें फिर ब्लैक
Mm.
होल और वो सारी चीजें भी पढ़नी पड़ जाएगी. तो
Mm-hmm.
इसलिए एक जो बहुत जनरलाइज डेफिनेशन है, तो हम अगर उस पर स्टिक रहेंगे तो आई थिंक हमारे लिए अच्छा है.
Okay, thank you.
I think gravity is vector, right?
या ग्रेविटी मेथड्स आर स्केलर, क्योंकि वो हमेशा ही डाउनवर्ड डायरेक्शन में पॉइंट आउट होंगे.
इन मतलब अर्थ पे तो सही है, हमेशा डाउनवर्ड होता है, लेकिन मे बी इन टोपोग्राफी करेक्शन में भी, फॉर एग्जांपल इफ वी आर लाइंग, इफ वी आर नियर अ माउंटेन, I mean it depends on the mass, right? For example, if we go to space and if there is a mass above us, okay, just imagine, then the gravity will be upwards, right? And we also use this r vector while we calculate all this gravitational
Mm.
and yeah, right,
Oh, no,
gm
so,
m by r square r cap, right? So I think it is to be vector.
हाँ होना तो एक्चुअली ये चाहिए क्योंकि इट इज अ
I think
कंजर्वेटिव
that is
फील्ड.
a scalar field or vector field. I think like that.
इट इज वेक्टर फील्ड.
है ना? Yes, it is vector.
हाँ, क्योंकि ये
Always
कंजर्वेटिव
use
फील्ड है,
vector.
दैट्स व्हाई हम स्केलर
हम्म,
पोटेंशियल डिफाइन कर सकते हैं.
हाँ,
ग्रेविटेशनल पोटेंशियल.
पोटेंशियल स्केलर होगा, हाँ,
हाँ हाँ.
स्केलर पोटेंशियल हो सकता
नहीं, पोटेंशियल स्केलर पोटेंशियल हम डिफाइन तभी कर सकते हैं ना, तब कंजर्वेटिव फील्ड होगा तो
है।
कंजर्वेटिव
वो
इसका
इक्को
मतलब वो.
पोटेंशियल के लिए, इक्को पोटेंशियल
हम्म.
के लिए आई थिंक. ठीक.
okay, तो it means the gravity field is a vector quantity.
Yes, I
Since we
think
are
so.
measuring that force, gravitational force, so force always vector. So force as these are the vector quantity. But I think gravitational field, that one is this scalar one.
No, no.
क्योंकि
Gravity
जितना
field.
मैंने सर्च
No.
किया ग्रेविटी फील्ड तो मेरे को स्केलर ही मिला. मैंने जितना भी सर्च किया मुझे भी पहले ये डाउट
Like
था.
the magnetic है ना, magnetic तो vector field है ना, like magnetic. But
मैग्नेटिक इज अ वेक्टर फील्ड. ग्रेविटेशनल
We always use
फोर्स.
we always use that r cap, right?
no,
And
no, what Bimal you said now that it is always
in gravitational field also, when we calculate for different bodies, then we have to take into account of the direction of the body, right?
बट अगर हम
We
अर्थ
always
के
use.
एस्पेक्ट में लेंगे तो हमेशा
हाँ,
वो
अर्थ के
डाउनवर्ड ही
स्पेक्ट में
ना
तो
होगा.
हमेशा डाउनवर्ड हो सकता है, तो we can say that
no,
in
no,
Newtonian.
you are saying about the force na, that what is force is always downward
Force,
na.
yes,
आई एम
gravitational
सेइंग
field is
ग्रेविटी
just
फील्ड.
force by mass, right?
Force तो
Field is just force by mass, right?
हाँ, यस यस.
And mass is a scalar, so if force is a vector, then field will be also vector, right?
एक बार
Okay,
स्टिल सब
so
लोग इसको क्रॉस चेक कर लेना, और जिसको
Okay.
कंफर्म हो वो प्लीज ग्रुप पे पोस्ट कर देना.
Okay,
Okay.
Gauri, you have any? Yeah, Gauri, you have any suggestion regarding Anjali?
He almost answered every question I asked, but I think he can improve the um, what I can say, some more precise or some more clarity in some cases.
Okay, thank you.
Okay, Bimal.
Yes, I'm sorry, I lost my connection at that time. So yes, I think answers were almost right, but I would say yes, as Gauri suggested, you should be a bit more precise. Okay, more precise. Okay, for example, when I asked about how to locate an earthquake, you should have started with Vadati diagram. Okay, because that is the first step in locating an earthquake. Then we measure the distance from the slope, and then we use the we draw circles, 3 circles, and then we find the epicenter. Okay. Okay. Rest of the things I think we are fine. Thank you.
Thank you.
Mohit sir.
हाँ सुदीप, ऑलमोस्ट आपका अच्छा था इंटरव्यू, एंड कुछ चीजों में आप इम्प्रूवमेंट कर सकते हो ना, जैसे कि बताया सबने कि थोड़ा सा प्रिसाइज होना है आपको चीजों में। कुछ क्वेश्चन ऐसे थे, देयर आर सम क्वेश्चन जिनका आंसर आप एकदम क्लियर नहीं दे पा रहे थे ना, तो उनको थोड़ा सा ट्राई करना कि थोड़ा सा स्टिक हो उनमें, एंड बाकी ओवरऑल अच्छा था।
Thank you.
हेलो,
हाँ, सजेशन हो गए ना सबकी तरफ से?
हाँ हाँ मोहित, हो गए हैं।
ओके, सो और कौन बाकी है? गौरी बाकी है क्या?
No, I have done yesterday.
ओके,
मोहित आप ही रह रहे हो शायद।
ओके, ओनली मेरा ही है। ओके, सो वी कैन स्टार्ट।
सुमना भी है।
और कौन है? हाँ, सुमन्ना। पहले सुमन्ना का कर लीजिए।
Okay, Sumana, any suggestion for me?
यस, पहले मैं हिंदी में बोलूं थोड़ा।
हाँ, English
कुछ भी
language या
लैंग्वेज।
तो ओके, थैंक यू। हाँ, पहले बात मेरा ये है कि आपका कॉन्फिडेंस लेवल बहुत सही था एंड क्वेश्चन भी आप बहुत अच्छे से टैकल कर रहे थे। और एक दो जगह पे अगर क्वेश्चन समझ में नहीं आए तो सर से ही एक बार डायरेक्ट पूछ लेना। और मैं क्या क्या पूछी थी, रुकिए मैं बोलती हूँ। शायद लास्ट क्वेश्चन, अभी हम लोग CG5 ग्रेविमीटर यूज करते हैं, ठीक है, फील्ड में। हेलो।
Yes, Sumana, thank
हाँ,
you for
हम
this.
लोग फील्ड में, हाँ, फील्ड में CG5 ग्रामीटर यूज करते हैं। और हम लोग जो बेस स्टेशन लेते हैं वो बैरन लैंड पे लेने की कोशिश करते हैं जहाँ पे कोई भी एनामोलस बॉडी ना हो, क्योंकि हम लोग तो रिलेटिव मेजरमेंट करते हैं ना, जहाँ पे कोई एनामोली नहीं है उसके रेस्पेक्ट में अदर जगह का मेजरमेंट लेना चाहते हैं, ताकि अगर कोई बाई चांस एनामोली हो तो उसका पता चले, ठीक।
Sumana, can you repeat this question again?
हाँ, मैंने क्वेश्चन किया था कि जब हम लोग बेस स्टेशन लेंगे, मान लीजिए ग्रेविटी या फिर मैग्नेटिक दोनों में ही, जब हम लोग बेस स्टेशन लेंगे तब वो कहाँ पे लेंगे? जो फील्ड एरिया है जहाँ पे हम लोग एनामोली एक्सपेक्ट कर रहे हैं सॉरी, जहाँ पे एनामोली एक्सपेक्ट कर रहे हैं वहाँ पे लेंगे, या फिर कोई ऐसी जगह पे लेंगे जहाँ पे हम लोगों को पता है कि यहाँ पे कोई एनामोली नहीं है, हम लोग श्योर है इस बारे में। तो हम लोग वैसी जगह पे लेंगे जहाँ पे हम लोगों को पता है बेस स्टेशन की कोई एनोमली नहीं है, क्योंकि जनरली हम लोग क्या करते हैं, ग्रेविमीटर से रिलेटिव ग्रेविटी मेजरमेंट करते हैं। अब रिलेटिव क्या है? जहाँ पे कुछ भी एनोमलस बॉडी नहीं है उस जगह का ग्रेविटी वैल्यू के रिलेटिव में, रेस्पेक्ट में, जहाँ पे एनोमली हो सकता है अदर कोई प्लेस का ग्रेविटी वैल्यू कितना चेंज हो रहा है, ठीक है।
Sumana,
अगर
and एक one question और था आपका जिसमें sign of anomaly for the ignition and the metamorphic rock.
हाँ, तो मैं बोली थी ना कि इग्नियस रॉक का डेंसिटी सबसे हायर होता है और सेडिमेंट्री रॉक का डेंसिटी लोअर होता है एंड बीच में मेटामॉर्फिक रॉक रहता है। तो अगर आप इंक्रीजिंग ऑर्डर में सजाएंगे तो वो होगा सेडिमेंटरी, मेटामॉर्फिक, इग्नियस। तो मैंने आपसे क्वेश्चन में बोल दिया था कि होस्ट रॉक दोनों में ही सेम है, लेकिन ग्रेविटी एनामोली एक में पॉजिटिव दिखा रहा है, दूसरे में नेगेटिव दिखा रहा है। तो क्या हो सकता है, सेडिमेंटरी या इग्नियस, कौन क्या दिखाएगा? तो तो यहाँ पे क्या हो रहा है, आप मान सकते हैं कि यहाँ पे होस्ट रॉक जो है वो मेटामॉर्फिक है, तो जाहिर सी बात है कि वो इग्नियस के लिए पॉजिटिव दिखाएगा और सेडिमेंटरी के लिए नेगेटिव दिखाएगा।
ओके, थैंक यू। एंड एनी सजेशन किस एरियाज में मुझे इम्प्रूव करना चाहिए?
आई कैन जस्ट गिव यू वन सजेशन टू यू ऑल दैट आप लोग फील्ड रिलेटेड एस्पेक्ट ज़्यादा पढ़ सकते हैं। मुझे एग्जैक्ट पता नहीं क्योंकि मैं जियो फिजिक्स बैकग्राउंड से हूँ, मुझे एग्जैक्ट पता नहीं कि फिजिक्स वालों से क्या पूछते हैं, लेकिन मेरे जितने भी जियो फिजिक्स के सीनियर डी है सभी एक ही बात बोलते हैं कि बेसिक्स पूछते हैं और बहुत ज़्यादा फील्ड रिलेटेड एस्पेक्ट्स पूछते हैं। तो मुझे नहीं पता कि वो लोग, शायद उन लोगों को भी तो पता है कि आप लोगों का इतना फील्ड नॉलेज होना उतना पॉसिबल नहीं है, बट स्टिल मैं बोलूँगी कि हो सके तो कुछ फील्ड रिलेटेड ये पढ़िए जो टेलफोर्ड में सबसे बेटर दिया हुआ है, फील्ड रिलेटेड एस्पेक्ट्स।
थैंक यू।
वेलकम।
मोहित।
हाँ, पहले सुमन्ना का कर लीजिए इंटरव्यू। ओके।
ओके ओके। अर्पिता, you start from your side.
Give me a minute. I'll be back.
Shanu?
Hello.
Yes sir.
Okay, am I audible now?
Yes sir.
Okay. Don't call me sir. Okay. Do you know that elastic rebound theory?
Yes, I know elastic rebound theory.
Okay, what is it? Is
Basically, elastic rebound theory is found in Sant Andreas fault, which is a reverse fault. So, in this case of reverse faulting, there is a okay, there is also a internal breakage in the uh, uh, foot wall portion, and that's why there is a large release of energy.
so it is found in only reverse fault.
Basically, elastic rebound theory is found in thrust faults or reverse fault. Yes, sir.
Okay. Okay, how many type of fault do we have?
There is normal fault, reverse fault, and transform faults.
Can you briefly explain what is
Yes,
this
sir.
fault are?
Sir, in case of normal fault, the hanging wall is in the above portion and the foot wall is in the below side. And in case of reverse fault, the situation is completely opposite. The hanging wall is on the upper side and foot wall is the below side. And in case of transform fault, there is no release of energy, no new landforms are created, only the two plates move parallelly.
Okay. As a Himalaya, you see that means you know that it's which type of fault in Himalaya
In
region.
case of Himalayan region, there is mainly reverse fault.
Okay. So, do you know that the fault plane mechanism?
Fault plane mechanism. Yes, sir, I know the fault plan mechanism. There is single couple and double couple mechanisms, but right now I can't recall the exact elaborated procedures of this, sir. Sorry, sir.
Okay. Okay, if you see that the earth means as, can you name that earth the layer which are the layer inside the earth?
Sir, basically, the earth can be broadly divided in crust, mantle, and core, and the crust, and we can say that there are two types of crust: oceanic crust and continental crust. Oceanic crusts are relatively thick compared to oceanic crust are relatively thin and younger compared to continental crust. There is upper mantle and lower mantle, where upper mantle both are solid, and outer core is also divided into two parts: outer core and inner core. The outer core is molten and rich in ferrous, nickel, cobalt, that type of materials, and created maximum magnetic field of the earth. I mean maximum internal magnetic field of earth.
Okay. And can you tell me about that means what is the mechanical properties of the each layer? Means crust, which is crust and the mantle and the core.
Sir,
Are you getting my question?
yes, sir, please repeat, and if you please, sir, please elaborate that what type of property you want to know
Means
about.
I am asking that it is solid, liquid, any type of thing. Means
Okay,
if
okay,
you,
sir, okay, sir. Sir, basically, crust is solid and it's basically composed of plates and is floating on the molten asthenosphere. The mantle, both mantles, upper mantle and lower mantle, both are solid. Only the liquid portion is outer core. Sorry, yes, sir. Only the liquid portion is outer core.
okay, means you, why the plate tectonic, you know the plate tectonic movement now.
Yes, sir. Sir, actually, the crust composed of mainly seven types of plates. The seven plates are named by seven continents, and
Okay,
these
okay. No, no,
plates.
I'm not asking that the content. But means
Okay.
why the plate are moving. Means
Yes, sir. These plates are floating on the molten asthenosphere, and they are continuously changing their position. Though it's a very slow rate, but still they are changing their position, and due to this change in position, the earth is dynamic and the plate tectonic motions has formed.
okay. So earthquake also reason for the plate tectonic.
Yes, sir. Earthquake is also reason of plate tectonic motion, and earthquake can also be done, like micro earthquakes can also occur due to some small faulting inside the earth. Very small faulting. That is, maybe that is not due to the plate tectonic motion. But still, if there is faulting due to any man-made reason, also there may be earthquakes, micro
Okay.
earthquakes,
Okay. What
whose
is the
magnitude are less than 3. Yes, sir.
okay, okay. Then why? What is the reason? Means what is the driving force of the plate movement? What is the reason plate is moving?
What is the reason? Sir, basic, basically the that's, sir, I am not sure about that, sir. Why the plate is moving.
Okay, okay, no problem. Okay. Now we come to one seismic question. So do you know the isostasy? Na?
Yes, sir, I know about isostasy.
Can you name the model of this model?
Sir, ARE model and Pratt model, sir.
Any other model we have?
Yes, sir. There is yeah, sorry. Wait a minute, sir. Venning model, sir.
Okay. Do you know that what is the basic principle of that model?
Yes, sir. In case of Pratt model, we are assuming that the height of the layers are fixed, but the densities are different. Basically, in this case, here, basically in case of Pratt model, we are taking horizontal density variation.
Okay, are in Benning model.
Sir, Venning model is related to the lithospheric flexure. I mean, if we I can explain. Yes. Let's say that if there is a massive body on something, in case of Venning model, we are assuming that the lithosphere is gone bended to adjust the massive body.
Okay, means it is also rebounding. No?
Almost rebounding, yes, sir. It's defined rebounding too.
Okay. Okay. Do you know the Adams-Wilson equation?
Adams Williamson equation. Yes, sir. I have heard about this, sir. Adams Williamson equation. Yes, sir.
It means. Can you know that what is the relationship it's explained?
Sir, Adams Williamson equation is basically explain the um, wait, sir. Yes, sir. The Adams Williamson equation is basically explaining the density variation with respect to R with G, I mean gravity and density.
Can you repeat, please?
Sir, as far I know that the Adams William equation was d rho dr is equal to minus gr rho r divided by phi r, where phi is alpha square minus 4/3 beta square, where alpha and beta are p wave and s wave velocities.
Okay. Okay. And next is it. You know that the VSP means vertical seismic profiling.
Yes, sir.
So why were so
Sir,
tell me about
VS.
what it is the VSP.
Okay, sir. Sir, VSP is basically a reverse of a full survey. In case of VSP, we are using several sources blasted in a borehole, and there is one receiver that is on the surface, and we are trying to record the upgoing and downgoing waves and also the multiples. VSP is basically used in case of seismic interpretation.
Okay, I'm done. Can anyone can ask? Hello, Pawan.
No, I take 2 and 3 minutes after that. This.
Okay, Gauri.
Okay, Sumana, can you name the seismic discontinuities within the Earth?
Okay, sir. Okay, ma'am. Sorry. Basically, they are Conrad, Moho, Gutenberg, and Lehman.
Okay. What is shadow zone?
Ma'am, shadow zone is the zone where we are not getting the reflected P waves, and its angular extent is 103 degree to 143 degree.
Okay. Can you name any waves that occur within this shadow zone?
Uh, I think, ma'am, it's diffracted P wave.
Any other one?
Sorry, ma'am, I can't recall any other right now.
Okay. Can you describe the variation of gravity within the Earth?
Yes, ma'am. Basically, okay, ma'am. Basically, the gravity is inversely proportional to r square, where r is the distance from the center of Earth, and the gravity is enormously decreased at Gutenberg discontinuity.
This decreased at Gutenberg's discontinuity.
Gutenberg, yes, ma'am.
Or it is the maximum value, shows maximum value. Which one?
Ma'am, it shows the maximum value at that point, then it starts decreasing randomly. I mean, at a very sharp rate.
What is its gravity value at the center of the Earth?
Mm, hello, yes, ma'am. I
What is
mean,
the
ma'am,
value? No.
ma'am, are you asking about the gravity value at Gutenberg discontinuity
No, at the center of the Earth.
at the center of the Earth? Ma'am, sorry, ma'am, I don't know about it.
Okay. What's the value of gravity at the surface?
Ma'am,
Generally. Yeah.
yes, ma'am. The value of gravity at the surface is gm by r square. So, if we put the value of r as radius of the earth, we will get the value of gravity at the surface.
Okay. Mm. Uh, how can you differentiate between a seismogram that is appearing due to earthquake and explosion?
Ma'am, in case of seismogram, there is a tug and pull motion. That is, there is a constant radial contraction and uh, ex- expansion. But in case of um, any nuclear bomb or that type of thing, there is the fast motion always is explosion. I mean outward.
Okay. How can you analyze whether the motion occurring at the focus is this formation of compression and refraction zone, or it is only expansion? What
Ma'am,
method? What is the method used to identify that a mechanism occurring around the focus?
ma'am, can you please repeat your question?
For analyzing the mechanism that is happening around the focus, we use a method by analyzing the seismogram records at different stations. What is that method called?
Um, Ma'am, are you asking about the Vaditi Benioff zone?
No,
Or
no.
okay, sorry, ma'am. Then I don't know, ma'am.
Wadati diagram is used to find the focal
Focal,
point
yes,
radius
yes,
and
ma'am.
distance, right? I'm
Yes,
asking
yes.
about the mechanism happening, how to analyze the mechanism happening around the focus.
Mm,
Uh,
sorry, ma'am. I can't recall it right now.
okay, that's all from my side.
Okay, ma'am. Thank you, ma'am.
Arpita?
Yes. Sumana, what is geophysical prospecting?
Ma'am, geophysical. Yes, ma'am. Are you saying something?
No, what is geophysical prospecting?
Okay. Ma'am, geophysical prospecting is basically a summation of methods to know to in case of maybe it may be used for exploring minerals or hydrocarbon or to map the internal structure of earth.
Okay. Are there any ways for the prospecting?
Yes, ma'am. The prospect basically, there are different types of prospecting. If we go for oil prospecting, then firstly we should use the gravity magnetic as reconnaissance survey, and if we get there any anomaly, then only we will go for seismic as it's very costly. After getting the velocity structure of Earth, then only we will go for well logging to confirm that it there is maybe there how what amount of oil is present in the subsurface. And if we go for mineral or coal, then we will try to avoid the last step or well logging. We just want to sum up the mineral prospecting by using various indirect methods like gravity magnetic resistivity, SPIP, that type of things.
Okay. So, Manna, what are the stages of exploration for the gravity survey?
Ma'am, for stage ma'am, are you asking about how to plan the survey?
Yeah. How to plan a gravity survey, basically.
Okay, ma'am. Ma'am, for gravity survey, we have to take first the GPS location of of that zone, that we can clearly know about the latitude and longitude, because in case of applying various corrections, we have to know them. Then we can then we can Hmm. Then we have to select our base station, and then we have to plan our survey. In case of gravity, we have to plot several grids we have to acquire the data on several grids, and the grid spacing is should be such that there should be at least three stations on the anomalous body. After acquiring the gravity data, we have to apply several gravity corrections on that, like Booger correction to remove the effect of mass between the datum plane and the body, free air correction to make the datum floating, then terrain correction to avoid the topographic undulation. That are the main corrections applied on the gravity. Then we will take the difference between the theoretical gravity value and the measured gravity value, and if we found some a value like a positive or negative non-zero value at that position, we can conclude that there is something anomalous in the subsurface.
Good. Can you explain what is a dynamic range?
Ma'am, dynamic range, the formula of dynamic range is basically 20 log A max by A mean, where A max and A mean is the amplitude of the seismic waves that recorded in the seismogram undisturbedly.
Okay, what is its unit?
Its unit is decibel, ma'am.
Why is there a need for the broadband seismometer?
Ma'am, I can't recall the it right now, but as far I know that broadband seismometers are accelerometers. They measures the acceleration. Am I right, ma'am?
Mhm. No, you are not right. Excel if you're saying that we are saying that broadband seismometers as accelerometers, then what do we say for the short period seismometer?
Sorry, ma'am. Then I am wrong. That's why I was getting confused. So broadband seismometers maybe are displacement meters, and short period seismometers are accelerometers. Actually, ma'am, I was just get got confused about that too.
Okay, but still it is wrong. Displacement meters are the long period seismometers.
Okay. Sorry, ma'am.
Can
Then
you?
I have to revise it 1 second.
Okay, no problem. Can you tell me what are microseisms?
Ma'am, microseisms are very small magnitude earthquakes, which magnitude is less than 3, and they mainly occur due to traffic and traffic, then making of dams and small faulting within the earth.
Okay, so on what type of seismometers we can locate the microseisms?
Ma'am, as they are very small in case, so we may use the displacement meter.
Okay, can you please tell me the classification of earthquake on the basis of epicentral distances?
Classification of earthquake on the basis. Acha. Ma'am, are you asking about the teleseismic events
Yeah,
and the other? Ma'am, basically there are teleseismic events which are occurs at greater than 20-degree angle.
okay, and any other earthquake on the basis of epicentral distance, or is there only a teleseismic?
Ma'am, if you are asking about the angle, then I can only recall the name of teleseismic events, ma'am.
I'm basically asking about the classification on the basis of epicentral distance.
On the basis of epicenter distance. Sorry, ma'am, I can't recall it properly right now.
Okay, no issue. What type? Can you tell me the division of the seismometer, different types of seismometer,
Ma'am, short period and long period seismometers.
and
Uh, Ma'am,
there
basically
are
these.
other on the basis of directions also?
Uh, um, Ma'am, are you asking about the components? I mean, horizontal components, seismometer, vertical,
Yeah,
that
on the
type of
basis of the Earth's motion. Yeah.
Earth's motion. Uh, Sorry, ma'am, I can't get it.
Okay. One thing more. Can you tell the reason of the attenuation of seismic waves?
Yes, ma'am. As the medium is not homogeneous and isotropic, the seismic when the seismic waves goes deeper down the earth, it got attenuated due to frequency dependence.
Okay. What is the term absorption coefficient?
Ma'am, basically absorption coefficient relates the basically absorption coefficient relates the amplitude of the waves at zero depth and at a certain depth z. Like a is equal to a0 e to the power minus alpha z, where alpha is the absorption coefficient.
Okay, Samana. Thank you. I'm done.
Okay, Sumana,
Yes, ma'am. Yes, sir.
introduce yourself.
Good evening, everyone. My name is Shumana Mondol. I am from Chinchura, West Bengal. I have done my graduation with physics honors under Srirampur College from Srirampur College under University of Calcutta. Then I have admitted to IIT ISM Dhanbad. There my discipline was 3 years MSc Tech in applied geophysics. After I have just passed out from this institute at 2020. My hobby is storybook reading and making embroidery on clothes. Thank you all.
Mm. So, which book have you read recently?
Sir, mainly I prefer to read Bengali storybooks and mythological books. Recently, I was reading. Not actually. I'm recently reading. I was just trying to revise Mahabharata.
So, can you name any book written by the Rabindranath Tagore?
Yes, yes, sir. The Are you asking about the storybooks or books of poems like a famous?
Any any book?
Okay, it's Sanchoita, Gitanjali. And there are several novels like Gora, Nonka Dubi, Jogajog.
Okay, very good. Okay, so let's come to the geophysics part.
Okay, sir.
What is elasticity?
Elasticity. Sir, elasticity is basically the property of a material. How, I mean, and it, how can I explain? It basically defines that if it interacts with any body, how it will behave.
Okay, so can you classify the materials based on elasticity?
Uh, yes, sir. There are elastic materials and plastic materials. If we, in case of elastic materials, if we apply strain on the material and then remove the strain, if we apply stress on the material and remove the stress, the material will go back to the previous stage. But in case of plastic materials, the material will not go back to the previous stage. They will contract to some extent.
Okay, good. Uh, So, what is Hooke's law?
Sir, Hooke's law is basically, we can say that Hooke's law. Sir, stress and strain shows a linear relationship. This is defined by Hooke's law.
So, in which region does it work?
Sir, Hooke's law will work into elasticity limit.
Okay. What is Poisson coefficient?
Sir, Poisson coefficient is ratio of stress to the orthogonal component of stress.
Okay. So, what can be its minimum and maximum values?
Sir, it will vary between 0 to zero point 0.5.
Can it be negative?
Negative Poisson ratio. No, sir, I don't think it may be negative.
Okay. What is the significance of this?
Sir, VP by VS versus Poisson's ratio, these graphs can be used as fluid indicator. Like we know that P waves can travel through every place, but S wave can't travel through fluids. So if we plot VP versus VS versus VP by VS versus Poisson's ratio, it may helpful to detect the shear zone or fracture zone within the earth which is filled with fluids or water.
Okay. So, what is the formula for in terms of the VP by VS?
So the formula is Vp by Vs is equal to root over 2 into 1 minus sigma divided by 1 minus 2 sigma. Here sigma is the Poisson's ratio.
So, what will be the value for the Poisson solid?
Sir, the value of Poisson ratio for the Poisson solid is 0.25.
No, no. The value of the VP by VS ratio for the Poisson solid.
The value of Vp by Vs for Poisson solid is root over 3.
Okay. So, what does it signify?
Sir, in case of Poisson solid, the Vp by Vs ratio is 0.3. Uh, that's the signify. Sir, the point, sir, this means that if the ratio, if Vp is 1.73 times the S wave velocity, then it is Poisson solid. I am not, matlab, sir, I don't know any other significance about that equation, sir. Sorry, sir.
Okay, okay. So, Earth is Earth behave as a Poisson solid or not?
Sir, not in all places earth can behave as a poison solid, sir,
Okay.
because
So
there are lots of heterogeneities in the earth. Yes, sir.
okay. So what is earthquake intensity?
Sir, sir, earthquake intensity. Sir, are you asking about the formula or you are asking about the
Just
definition?
just just define the definition. Just
Sir, earthquake intensity can be termed as the, sir, basically earthquake intensity is maybe termed as the, it can be seen, I mean the amount of distractions created by the earthquake.
okay. So on which factors does it depend?
Sir, the earthquake intensity will depend upon the energy released by the faulting and the magnitude of the earthquake.
Okay. So can you give any distribution of earthquakes, worldwide distribution of world earthquakes, how earthquakes are distributed?
Sir, sir, yes, sir. The maximum earthquakes occur in the maximum earthquakes occur in the Pacific, throughout the Pacific Ring of Fire. And ma'am, yes, ma'am. Sorry, I can recall the classification of earthquake depending upon the focal depths. Ma'am, it's a shallow focus earthquake, deep focus earthquake, and intermediate focused earthquake. And
Okay, okay. This I was asking about the distribution. Okay, okay, no problem.
sir,
Can we predict earthquake?
yes, sir.
Can we predict earthquake?
Yes, sir. We can predict earthquake.
How exactly?
Mm. Sir, like before some main shock has come, there should be some force shocks. So we can analyze the force shocks and predict them when the main shock will come. And also there is a earthquake frequency relation, which is depending upon b value, like log n is equal to a minus b ms, where a is a constant and we have to calculate the b value, and n is the frequency of earthquake. From that relation also we can predict the earthquake, sir.
So is this relation, is there any name for this relation? It
Sir,
is any law?
seismic b value equation, sir. This equation is known as seismic b value equation.
Okay. What is dilatancy theory?
Sorry, sir, I can't recall it right now.
Okay. So what is the difference between prediction and forecast?
Sir, forecast. Sir, forecast is wait, sir, prediction is basically by analyzing the circumstances. We are just trying to say that there may be some earthquake, and forecast is kindly sure type of things, that there will be a earthquake at that time. This type of thing, sir. I think, sir. I'm not sure. I'm not fully sure about that.
Okay. Uh, do we have any early warning system for earthquake in India?
Sir, maybe it may, sir, I am not mm, sure about that, but sometimes we can predict, matlab, scientists one try to predict the earthquakes by before that, before tsunami, like the sea goes back, goes away from the shore. That type of things we can, from that type of things we can predict the earthquakes, sir. I think.
So, okay. So, how can early warning system help us to predict the earthquake?
Sir, that I don't know, sir, properly. Sorry, sir.
Okay, no issue. So, do you know the fundamental forces of nature?
Sir, gravitational force, strong force, and weak force. And gravitational force, strong force, weak force. Yes, sir, that three types of forces.
So, there are only three type fundamental forces.
There are
How many type of fundamental forces are there?
gravitational force. Wait, sir. Sir, there are I think there are four types of fundamental forces, sir.
Okay. So, what is the range for the gravitational force?
Sir, it's 10 to the power minus 37.
What in what
No,
unit?
no, sir. No, no, sir. I mean, sir, I am trying to say that it's 10 to the power 39 meter, I guess, sir. It's a very long range force.
Okay, it is a very long way. So, you have ordered this number in which unit?
Sir, if we sir, if we are taking that in minus, then it will be the about the energy of the forces, like how much it's stronger or weaker than the others. But 10 to the power 39 is meter, I guess.
Okay, okay. So, last question. Suppose you have the hydrocarbons, minerals, and groundwater.
Hmm.
So which method will you prefer among the gravity and the seismic, and why?
Sir, if there is hydrocarbon, mineral, and water, all three present in a particular zone, then we will try to apply seismic there, because in case if we you apply seismic, then we can easily differentiate between those three. But if we apply gravity, then maybe we can identify the mineral, but we cannot surely predict the presence of hydrocarbon and water at that point.
What is the range of the velocity, seismic velocity in water and mineral?
Range of seismic velocity in mineral.
Yes, just P wave velocity.
Sir, sir, as far I know, that P wave velocity may vary from 8 to 13 meter per 8 to 13 kilometer per second in the earth, sir.
Okay, thank you, Sumana.
Thank you, sir.
Okay, Mohit.
So, Sumanna, you are from Kolkata, right?
Yes, sir.
Yeah. How the geological structure of Kolkata is?
Sir, basically, Kolkata is on Gangetic Basin, so it's on sediment. It's mainly composed of sedimentary rocks.
Okay. And how about the earthquake in Kolkata?
Sir, Kolkata is not in the earthquake-prone zone, but if we go east from the Kolkata, or we can go for the northeastern section, so it will be a very much earthquake-prone zone, sir.
Okay. And you have done MSc MTech in geophysics, right?
Yes, sir.
Okay.
It's MSc Tech. Huh?
Okay. So how a dual 2 years degree in MSc geophysics and 3 year degree in MSc MTech, how they are different? What the special thing you have done in that 3 year course?
Sir, in that 3 year course, we are not only taught about the research perspective, but the name of our course is Applied Geophysics. So we are mainly focused in the application of it in oil as well as mineral sector, sir.
Okay,
and
which
it will
geophysical, yeah, बोलिए.
and it's mainly concentrated in various fieldworks like geological fieldworks and geophysical fieldworks, though our geophysical fieldwork was cancelled due to corona.
Okay, so you have done no any field work.
uh, Sir, I have done a field geological field in Jharia coalfield, sir.
What you learned from there?
Sir, I have learned from Jharia coalfield. We all have seen various type of rocks. Basically, as it's a coal bed, so there was a huge layer of sedimentary rocks, and there was a strange thing that there was a rail station, and one side of the rail station reveals the Borakor formation, and the another side of the rail station reveals the Talcher formation. So the quality of coal was different, differentiated a lot due to that small gap, and then we have seen various type of geological structures like folding, faulting, and geological ripple marks from which we can detect the age of rocks.
Okay. How do we determine the age of rock?
Sir, mainly we can use the radiocarbon dating for detecting the age of rock, but if we will follow the ripple factors, we can say that yeah, ripples are generated. So ripples basically generated if there was a uh, water body passed through the rocks, then ripples are generated. So if we know that after before what hours there was a river passes through the land, we can almost mostly predict the age of the rock, sir.
Okay, you use two terms, fault and folding. Can you describe
Yes, sir.
it?
Sir, fault is basically, in very layman's language, if there are two plates situated at a situated at same level, but suddenly due to some reason, one is go down the another, then this type of situation is known as faulting. This is mainly created due to earthquakes or plate tectonic. And sir, folding is folded when a straight slab of rock or strata, we may call it strata got folded due to high pressure or temperature type of things. I mean, some due to some external issues.
Okay. The folding method is used in seismic survey or not?
Yes, sir. Folds are analyzed in seismic survey because in case of cap rock, that nature of cap is basically the folds. Like anticlines used termed as caps in seismic survey.
Any mathematical formula finding out the fold?
Sir, there is I don't know any mathematical formula to find the fold, sir.
Okay, okay. So you have done the field survey where you have used which of the which methods you use there?
Sir, can you please repeat your question?
You have done a field survey during your MSc MTech degree. So which methods you used there?
Sir, actually, our field was got cancelled due to corona. But as far I know that we can use very like surveys for we for sulfides body or any massive body, we can use gravity survey. For minerals which having magnetic property, we can use magnetic survey. The for minerals which have for metals which have disseminated materials throughout the pore spaces or its rock matrix, we can use IP survey, and to map the groundwater too we can use SP survey.
Okay, tell me three applications of seismology, seismic method.
Sir, seismic method are basically can be used for earthquake prediction to map the internal velocity structure of Earth, and the active seismic or active seismology or seismic method is used in case of hydrocarbon and mineral exploration.
Okay, how this hydrocarbon exploration is done using seismic survey?
Sir, for hydrocarbon exploration, basically we have used seismic survey to fully get the velocity structure of the subsurface. For this, firstly, we have to apply the refraction method. By refraction method or AFOL surveying, we will get the velocity of the weathered rocks, which are further used for static correction. Then we will use seismic reflection survey to know the exact position of subsurface layers. After the data acquisition has completed, we have to go through various processing sections to detect the seismic velocities properly.
Up to what depth we can use this seismic method?
Sir, up to what depth? Sir, I am not sure about the depth range of seismic, sir. Sorry, sir.
Okay, you use the term static correction. How many types of correction are there in seismic survey?
Sir, static, there are mainly two, in a broad way, there are mainly two types of corrections: static corrections and dynamic correction. Static corrections are basically used to remove the effect of surface undulations between the source and the geophones. Static correction basically done what that it makes the same datum for the source and geophone. And the dynamic corrections are, there are several dynamic corrections like normal move out correction and DOMO correction.
Okay, and what is migration in seismic survey?
Sir, Sir, in case of dipping bed, the reflection points are shifted down deep. So, to relocate the reflection points at their exact point, or we have to move the points up deep. This process is known as migration.
And what is staking?
Sir, stacking. Sir, stacking is basically done to remove. Sorry, sir. Stacking is basically done to improve the signal to noise ratio.
Okay. Okay, you use the term surface undulation. What is this?
Sir, surface undulation is basically topographic variation. Like, let us say that we have planted our geophone in a hilly terrain. We have used, as it is hilly terrain, we have to use dynamite source. So, the height where we planted the dynamite and the height where we planted the geophone are not same. So to remove the effect of high difference in the height, we have to apply the static corrections.
What is the principle of geophone?
Sir, principle of geophone. Sir, geophone in in case of geophone, we use some piezoelectric crystals. I mean, in case of geophone, basically what we done, we are converting the mechanical energy into electric energy.
Okay. How many type of geophone do you know?
Sir, I know only one type of geophone. I am sorry, sir. I can't recall the types of geophones right now.
Okay. Okay, assume that you got a signal in geophone, and what will be the further process?
Okay, sir. Sir, let we have the input trace or the input data. So firstly we have to demultiplex the input data file. demultiplexing is basically writing the data in a matrix form where each column of the matrix is representing the data due to a same shot, and the different columns are showing the different offsets. After getting after we apply the demultiplexing, we have to apply the, sorry sir, give me some time. Sorry sir, actually there is some issue. Sir, after applying the demultiplexing, we have to edit the traces, like if there are any abnormal peaks or abnormal draw found in case of seismic section, we have to remove that. Then we have to apply TAR, or true amplitude recovery, where because we all know that the amplitude of the seismic signal decreases with depth, so there may be some difficulty to interpret the section. That's why we have to apply the TAR. Then we have to apply initial filtering. Initial filtering is consist of FK filtering and velocity filtering, that types of thing. Then we have to apply deconvolution to remove the source wavelet from the seismic trace. Then after decon, we will pick our random velocity by brute stacking, and we will do enemo correction with that velocity. By enemo correction, we will get from the overcorrected or undercorrected type of things, we will get the idea of a proper velocity. After doing the enemo correction, we will go for muting to mute the enemo stretches. After muting, we have to stack all the traces from same shot. After stacking, we have to apply residual statics, like if we have applied lots of correction, but if there is some abnormal peaks or something there, we have to chop them down. After chopping the abnormal stresses, we have to do the velocity analysis again to pick the original velocity, because in seismic our motto is to build up a perfect velocity model. Then we have to apply DMO, which is a pre-stack migration. Then we have to apply migration, the full migration, like post-stack migration, and then we can interpret the processed seismic section.
Okay, you use filtering and the
Yes,
FK filtering and another one, right? So what is the difference between these two?
sir. What to, sir? Filtering and,
Yeah, the filtering, you use two types of filtering, right?
yes, sir. Sir, basically we can use the FK filtering and velocity filtering in case of filtering. Like in case of, if we put FK filtering, we can surely show the linear events. So, and we know that high velocity, high amplitude linear events are ground rules. So surely we can move out them, chop them out. And the velocity filtering is also used to remove ground rolls, because the velocity of ground roll is very less compared to the seismic signal, so they will come later than the signal, and we can chop down the later parts.
What is this ground roll?
So ground roll is basically a Rayleigh wave, which when appears at a seismic section, this can be create a confusion to pick the fast break, or the fast break is the fast reflected signal.
Okay. You say that amplitude of an seismic signal decreases with the depth.
Yes, sir.
Can you give a reason for that?
Sir, due to anelastic attenuation, sir, and geometrical spreading.
Okay, so there are two types of things, geometrical spreading and attenuation.
Yes, sir.
So there is a term known as Q factor. What is this?
Sir, Q factor is basically shows the energy changes per cycle delta E by E, where E is the energy of per cycle.
Okay, Sumanam, tell me what is filter?
Sir, filtering is a process which tries to remove the unwanted elements from any data.
Okay. Can we say that art is a filter?
Yes, sir. Arts maybe act as a low pass filter because if
But
we go deeper by the earth, it can be seen that only the low frequency waves are alive and others are attenuated.
okay, so what is the reason that the high frequency signals are attenuated and low frequency signals are not attenuated?
Sir, what is that? Because sir, dispersion,
What is
the
this?
sir dispersion is sir, the high frequency, the because this no sir it's a diffraction, sorry sir, I mean sir, I want to say that high frequency signal will be diffracted more than the low frequency one, sir.
What is this diffraction?
So diffraction is basically a phenomena of wave when a wave is going through a very like a side of blade, very sharpened edge. Its straight line nature goes. Its straight line nature is. I am not getting the correct word. It get distracted from the deviated from their straight line nature.
Okay. You use the term NMO correction. Can you tell
Yes.
me on which factor this NMO correction depends?
Sir, basically, NMO correction is time at a offset and the difference between time at a certain offset and the zero offset time, and it mainly depends upon the offset, velocity, and depth.
What is the formula for NMO correction?
Sir, basically we are using the basic relation t square is equal to t0 square plus x square by v square, where t is the travel time for x offset, t0 is 0 offset travel time, and um, x and v, x is the offset and v is the velocity, and delta t is, I am not sure sir, but I think delta t is x by 2 v square t.
Okay, okay. So in this seismic reflection survey, can you tell me what are they?
Yes sir,
In
in
the field,
seismic reflection.
in the field survey,
Huh?
in the field survey, in order to find out the waves, to detect the waves, we use the geophones. The arranging of geophones. On that factor, we use two types of method. Do you know that?
Sir, actually, sir, can you please repeat your question? I can't hear it properly, sir. Are you asking about the, are you asking about this different spreads, different arrangements of geophones?
Yes, yes.
Sir, there are basically two types of spreads, end-on spread and split spread.
Can you briefly explain these two?
Yes, sir. In case of split spread, let us say that there is a shot in the middle and equal number of geophones are distributed at the two sides of the shot. And in case of split spread, yes sir, this is split spread one. And in case of end on survey, a shot is the geophones are only arranged at one side of the shot. The basic difference between those two are, in one case geophones are arranged both sides of the shot, and in the another case the geophones are placed at only one side of the shot.
Which one is most useful?
Sir, the first one, or the split spread, is more choosable, sir, because by this we can generate a end on survey by making the half section of the split spread survey.
Okay. Do you know the total gradient method?
Sir, total gradient method in what? I mean, sir, I'm not getting it. Sir, is are you asking about the gradient method in gravity? Gravity gradient survey.
No, the gradient method we use in seismic reflection survey. Is there anything?
The no, sir, I am not aware of this, sir. Sorry, sir.
Okay, okay, no problem. And then you use the term traces. Can you tell me what is this?
Sir, traces are basically, how can I explain? Sir, traces are basically the source wavelet convolved with the Earth's internal reflectivity series.
Okay, do you know the multiples in
Yes, sir. Multiples are one type of noise present in seismic reflection survey. This is generated due to multiple reflections. Multiple reflections at any layer.
Okay, can you briefly explain what type of these reflections? Any name?
Sir, there are peg legs or ghosts, or in case of marine, there are reverberations.
Okay,
These are
can you
different types of.
explain the differences between them?
Yes, sir.
The differences between tag leg and ghosts.
Yes, sir. In case of peg legs, the peg legs are basically a long path multiples, and they are appearing at the end of the seismic section, and also the peg legs are basically generated due to multiple reflections from any intermediate layer. But in case of ghosts, the ghosts are basically generated due to an unknown deviation of seismic wave from the reflection from the bed, sir. Like, if I can draw, I can explain more easily that. Uh, ah, Sorry, sir, I can't explain it in proper way, sir.
Okay, okay, no problem. Okay, thank you.
Thank you, sir.
I think all are done, na? Okay, give some feedback.
Okay.
Okay, so yeah.
Yes.
Okay,
Yes.
Sumana, your concepts are good. Okay, the two things that I would like to add there, in the process of giving answer, you repeat the question what the interviewer is asking. Huh? This is not a good thing. Okay, and sometimes आप क्या करते हो कि जो आपका आंसर है वो एक्सप्रेस करने की बजाय थोड़ा सा आप अपने मन में बोलते हो उसको तो वो आपकी आवाज सुनाई देती है ना तो उसके ऊपर आप थोड़ा सा वर्क करें बाकी कंसेप्ट सब अच्छे हैं कॉन्फिडेंस आपका अच्छा है ओके
Okay, sir. Thank you, sir.
Okay, Asuji.
हाँ, हेलो। हाँ,
हाँ,
कि वही जो मोहित ने बोला है कि एक तो वही है, आप बार बार मतलब रिपीट कर रहे हो क्वेश्चन को, अच्छा अभी ये बताना है क्या, वो बताना है, सो अवॉइड फ्रॉम सच थिंग्स। बाकी कॉन्सेप्ट सब अच्छे हैं एंड आंसर भी अच्छे दिए हैं आपने, ओवरऑल गुड।
सर मेरा एक क्वेश्चन था, वो है कि मुझे क्या और भी प्रिसाइज करना चाहिए या फिर डिस्क्रिप्टिव वे में ही बोलना चाहिए? इसमें मैं कभी कभी परेशान हो जाती हूँ।
देखो वो तो मैंने एक सर से कल भी पूछा था, आज सर से, बिकॉज इट डिपेंड्स ऑन द क्वेश्चन कि व्हाट इज द डिमांड ऑफ द क्वेश्चन। अब सपोज एग्जाम पूछा जाए कि व्हाट इज द क्लासिफिकेशन ऑफ द ग्रेविमीटर्स, जस्ट विल क्लासिफाई कि एब्सोल्यूट रिलेटिव। फर्दर पूछा जा रहा है कि क्या होते हैं, देन वी कैन एक्सप्लेन। सो टोटली डिपेंड्स ऑन द डिमांड ऑफ द क्वेश्चन।
ओके सर, थैंक यू सर।
Okay, Hospita.
ओवरऑल इट वाज गुड, और रेस्ट मोहित और आशुदीप ने बता दिया है आपको, और इट वाज गुड।
थैंक यू मैम।
Gauri.
Your confidence level was good, but I think you're making some um, mistakes. I have noticed in the first question about the elastic rebound theory, you are explaining about the San Andreas fault, and you are mentioning it as reverse fault. Actually, it is transform fault. There, there was no need of mentioning about it, but you are unnecessarily including it and making it wrong. Like that, in some cases you just need to be precise.
Yes, ma'am. Ma'am, sorry. Actually, my fault is that I have not revised the seismology method again. That's a shortcoming of my preparation till now.
Sumana, not need to be sorry here. We are just here for the finding our mistakes so that it will not experience in the interview room. Okay.
No, actually.
Okay. Pawan.
हाँ यस, सुमन आपका कॉन्फिडेंस लेवल अच्छा था और आप डिलीवरिंग भी क्वेश्चन की अच्छी कर रही थी, ओवरऑल गुड। बट मेरा एक क्वेश्चन ये है कि फील्ड में जो टाइटल करेक्शन है और जो ड्रिप करेक्शन को कैसे एस्टिमेट करते हैं फील्ड में?
Sir, in case of matlab if we are going for magnetic survey, there are a specific drift correction process. Like we are taking the reading of magnetic value at मान लीजिए at 10 a.m. Then we have to complete the survey and all have to retake the reading of the gravity value at that same point at the end of the survey, and then we have to take the differences between them, like if b0 minus bt divided by t1 minus t2, where b0 is the reading of gravity value at the initial point time and bt is the reading of gravity value at the final time, and t1 and t2 is initial time and final time. Then we have to subtract this if we are doing the survey at the morning, and we have to add this if we are doing the survey at evening, because the gravity value magnetic value varies a lot with time. It will start increasing up to 4 p.m. and then it will start decreasing.
ओके, तो मेरा सेकंड क्वेश्चन मेरा ये है कि व्हाट द डिफरेंस बिटवीन द पारसनिक मेथड एंड नेटल्टन मेथड? आई आल्सो सम कंफ्यूजिंग।
सर एक्चुअली मुझे भी बहुत ढंग से तो याद नहीं है, तो फिर एक बार अगर देख के मुझे बोलना पड़ेगा सर।
ओके ओके।
As far I know that Nettleton's methods are used to find the density of body. Am I right? And I have forgotten about the Parsonage method, sir. Sorry, sir.
या ओके, आई एम डन।
Anu,
Simon, okay, I'm giving feedback.
Yes, sir.
Okay, as I see that your communication skill is good and your confidence also good, and but as they are suggesting that you would need to be little bit means mono means you are repeating your word
Yes,
a
sir.
little bit you calculate and
And I have to
that,
revise the seismic.
yes, I know that you got very less time, just 1 day to revise this time, and so I think that you have great potential, so you can do better.
Thank you, sir.
हाँ एक चीज और सुमाना कि आप ना क्वेश्चन थोड़ा मतलब एक पहले अच्छे से सुना करो बिल्कुल। कभी कभी ऐसा लगा है कि जैसे कि मैंने क्लासिफिकेशन पूछी थी, डिस्ट्रीब्यूशन और थॉरस्टन पूछा था और आपने क्लासिफिकेशन बताना स्टार्ट कर दिया था।
Hmm.
एंड सो एक जगह और हुआ था, सो क्वेश्चंस को पहले सभी के लिए ही है वो तो कि क्वेश्चन ध्यान से सुनो बिल्कुल।
Okay, sir. Sorry.
सो नेक्स्ट सेशन किस उस पर रखना है, फिर कब रखना है?
तो नेक्स्ट इलेक्ट्रिक पे रखते हैं, इलेक्ट्रिक
पवन, यू कैन एंड